Hello there, welcome to Let's Analyze with Irat. I'm happy to welcome you to the Introduction to SQL playlist. This playlist will contain practical hands-on SQL tutorials where you would learn how to query and analyze database with MySQL Workbench, while also gaining skills in database management and data manipulation. If you haven't subscribed to this channel, make sure you hit the subscribe button before we proceed with the course. Before I start, I need to give you a brief introduction to the theoretical part of SQL, like the definition of SQL. SQL can also be called SQL, which the full meaning of SQL is structured query language, and it's used for manipulating or managing relational databases. Its purpose is to store, manipulate, and retrieve data within a relational database. Sometimes you might ask yourself, why do you need to learn SQL? SQL can be used for data analysis, like loading, querying, and analyzing massive data sets efficiently. There's an high demand of SQL skills in various industries. And it also gives you endless applications in data management and analysis. The brief history of SQL. SQL was developed by IBM for relational database management in the 1970s, and they are still in existence till date. SQL is a universal standard set by ISO and ANSI. SQL language has changed over the years. There are different flavors of SQL. You have MySQL, you have SQLite, you have ProgressSQL, and the likes. These are different flavors. All these languages or all these flavors still use the same SQL language. The only difference you might get to see is the difference in the interface, as MySQL Workbench might be different. The appearance or the interface is different from the interface of a PostgreSQL application. But for this course, we'll be using MySQL Workbench. Before we move straight to MySQL Workbench, I also want to discuss what a database is and what a relational database is. A database is a structured set of data held in a computer. When I say structures, that means it has rows and columns like a table structure. This database is controlled by the database management system, and we have the relational database management system. This stores the data in the table related by column fields, and it provides relational operators to manipulate the stored data. So I'm going to move us straight to MySQL Workbench to understand the interface of MySQL Workbench. After understanding the interface, we would move straight to understanding SQL statement types. Right. So here's the MySQL Workbench interface. If you haven't installed MySQL Workbench, you can watch a video on how to install MySQL Workbench. It's actually very straightforward. Here, you'd be asked to log in with your root ID or your root password. Because I already logged in, that's why I'm already in the local interface. But before you log in, this is the welcome interface of the MySQL Workbench. Here is the home page. You have here where you can create your models, and we have another interface. I'm going to discuss how you can create your EHR diagram or models. That would be later. But for now, let's just understand the local interface of the MySQL Workbench. Over here is the schemas pane. Here you'd have access to the schemas and also have access to the administrations. The administration role contains information about the management, the instance of the servers, and also the performance of the servers. This is a little bit advanced. You don't have to know that as a data analyst. You can just have the knowledge as an advanced knowledge. But for now, since you're a beginner, let's just focus on the schemas. Here, I've already created the schema. If this is your first time is if this is your first time importing the MySQL Workbench, all you would have is this SYS schema. But I have already created this schema. This is on a private project. We'll be creating our own schema when we are done discussing the basic data statements. Over here is where we get the action output. We haven't gotten an action output yet because we haven't run any query. But as soon as we run a query, we would get the output of the action. Over here is the information pane. Here we get information about a particular schema or a particular column. Using this as an example, you'd notice whenever I click on a schema name, it will give us the schema name. If I click on the drop down and I select a table name, you'd see that we have information about the table, the columns in the table, and also the data types of the columns in the table. Here is where the magic happens on the query pane. Here we are going to write our script, our SQL language script. And here we are going to run our script, save our script, and also import scripts. We also have access to collapse these pins. We can collapse this pin by clicking on this button. We can also collapse this and collapse the SQL additions. If you need a wider interface, let's say you want to expand the interface, maybe the code is exceeding the interface you have, you can collapse the unnecessary interfaces or the unnecessary pins by clicking on these buttons. Okay, so let's create our first schema. But before we create our first schema, I want us to learn about the SQL statements types so that we can understand the basic statements types. We have the SQL statement types. The first one we'll be discussing is the DDL. DDL, which means data definition language. Data definition languages are used to create or manipulate the database structure. So it's majorly used for creating things like the schema, tables, to alter tables, to delete tables, drop tables, and the likes. It focuses mainly on the structure of the database. The second one we'll be discussing is the data manipulation language, that's DML. Data manipulation language is used for managing the data records. It's used for extracting records from the database as well. Examples are the select, insert, into, updates, and the likes. The third SQL statement type that we'll be discussing is the data control language. Data control language is used for granting and revoking permissions. The fourth SQL statement that we'll be discussing is the data transaction language. Data transaction language is used for managing transactions like the begin, commit, and rollback. Let's move straight to MySQL Workbench. Here I'm going to be creating our schema. There are two ways you can perform an action in MySQL Workbench. You can either write the query or use the user interface. SQL Workbench has already given you access to some buttons that would automatically create a query statement for you instead of writing the statement. I'll be showing you the two methods. I would advise you learn how to write the query so that you can understand the idea behind this. I'd advise you learn how to write the query language instead of focusing on the user interface, especially as a beginner, so that you can understand how to use the SQL language properly. The first thing we need to do when we want to create a schema is to use the create statement. Create statements, let me increase this so that we can have a closer look. After writing the create, we need to specify what we want to create. In this case, we want to create a schema, right? a schema which is going to be our database. So we'll specify that it's a schema we want to create. Schema. I'm spelling that wrongly. Okay, schema. So after writing what we want to create, which is the schema, we need to specify the schema name. We need to specify the schema name. So let's call this, since it's our first schema, let's write my first schema. Right. You'd notice when I was writing, before completing this line or this statement, I was getting a cross sign, which was indicating that there's an error in the code. So what is happening is SQL is looking at the line. As I'm writing the statement, it's looking at the line, it's capturing the errors and indicating that there's an error in case, just so I can know that I'm not done with the statement, because this statement would give me an error if I run it. Okay, so let me just cut this out and I'll show you the difference. Now you'd see that I have the cross sign, but when I specify the schema name, you'd see that I don't have an error. Okay, so I can run this using one of these two. I can run this using one of these two icons. I can use this icon or this icon. They both do the same function. However, they have different uses. For this, it executes the statements under which the keyboard cursor is. This cursor is this the line that is beeping. That's the cursor. While this is used to execute the selected portion of a script or everything on the script. So if I select this portion, let's say we have other statements in this same script. If I select this portion and I run with this, it would run just these statements that I've selected. However, if I don't select a particular section, it will automatically run every statement on this query pane. Okay. While this would just run the statements that has the icon or cursor on it. So I'll run this, and here is the action output. Under the action output, you can see that there's a number given to every action. This is the first action I'm creating. That is why I can see number 1. And also you can see the code or the query that was executed. You can see the number of rows that were affected, and also you can see the time it took for the action to run successfully. When you go to the schema pane where you're expected to see your new schema, you might not see your schema immediately. All you need to do is refresh using this icon. When you refresh, it will refresh the schema pane and you get your new schema. You notice when I click on the drop down, there's no table, there is no view, there's no stored procedure, neither is there a function. That is because we only created a schema, we haven't created a table. So we are going to do that next. But before that, I want us to understand the different data types in MySQL language. So let's go straight to our PowerPoint presentation. Right. So there are different data types. We have data types for strings or text values. We have data types for number values. And we have data types for dates or time values. For the string data type, we have the char, varchar, and binary for storing text and binary data. We have, under the numbers data type, we have tiny integer, small int, big int, and decimal for storing numerical ranges. Also for the date or time data type, we have the date time, and timestamp for storing temporal data. We also have what we call the SQL constraints. SQL constraints are the rules that are applied to columns of a table to ensure the accuracy, reliability, and integrity of the data. An example is the not null constraint, This ensures that a column cannot have a null value. That means a row in a column must not be empty. So for us to maintain, this is a very efficient way of maintaining the data accuracy and the data integrity. Another example is the unique constraints. Unique constraints ensures that all value in a column are different. For example, if you are trying to create a product table, right? A product table is expected to contain unique informations about the table. In that case, the product ID, which is going to act as the primary key, must contain unique values for each rows. So we are not expected to get product ID 1 repeated twice in a product table. Okay, so unique constraints helps us to ensure that the so unique constraints helps us to ensure that the column contains only unique values. The third constraint is the primary key. Primary key is a unique identifier for each row in a table. A primary key is a combination of the not null and the unique constraints. So it's uniquely identify each rows in a table. The fourth constraint I'll be discussing is the foreign key constraint. This foreign key prevents actions that would destroy the links between tables. It ensures that the value in one table matches the value in another table. So it links tables together by referencing the primary key. If you don't have an understanding of this primary key and foreign key prior to this tutorial, it might be a little bit tricky now, but I'll try as much as possible to explain very well. But if you still have an issue understanding the primary key, foreign key, or normalization, you can indicate below in the comment section and I would make a separate video on that. These four constraints are the only constraints I would be discussing. We have other constraints like the check constraints that ensures that the values in a column satisfy a particular or a specific condition. That is a different constraint. We also have the default constraint that sets a default value for a column if no value is specified. So instead of having a null value, it would automatically input a value. Okay, that is a default constraint. After discussing these two, I want us to go straight into my SQL workbench to create our tables. Before I proceed, I want us to always make sure to add a semicolon at the end of every statement. Now, the reason we add a semicolon is to specify or to indicate to my SQL workbench that this statement has ended. Okay? If I don't impute this and let's say I want to write a different statement that says create table. Let's call the table name products. If I try to run this, I'll be getting an error. So the error here, from the error message, we can see that the error is you have an error in your SQL syntax. You have an error in your SQL syntax. So you might not understand where the problem is coming from, especially as a beginner. But one thing to always keep in hand, one thing you should always do as a practice is as soon as you're done writing a statement, always add the semicolon at the end. Before I run this, I want you to note that we haven't specified any schema to be used. Okay, we need to specify. If I try to run this, I would still run into an error because we haven't specified. From the error message, you can see it says no database selected. So we need to set a default database that this table is going to be created into. So there are two ways we can do that. We can do that by using the user interface or by writing the code. I would prefer us to write the code so that we can understand SQL language better. All I need to do is write the use, and I'll specify the schema name. So the schema name is my first schema. And of course, I add my semicolon. When I run this statement, I wouldn't get an output. But if you notice, over here, we already have my first schema and a bold format. Okay, this indicates, or this shows us that this schema has been set as our default schema. Okay, now when we want to run this statement, create table product, if I run this, it wouldn't run, obviously, because I only created a table without specifying the columns and the data types that should be in the column. Okay, so this statement is now finished. We need to continue the statement. So for our products table, let's say we have the products ID. Okay, let's keep this in a space. And before we proceed, you'd notice I've been using uppercase, that's capital letters or uppercase, whatever you call it. I've been using the uppercase for statements like create, table, and use. Note that this is just a method of writing statements to make it readable. Okay. If I write this in lowercase, this statement will still run because SQL is not case sensitive. SQL also doesn't care about the indentation of your statement. So instead of writing instead of writing a statement in a line, I can break it into different lines. So now that I want to specify the column names, I can write it in the next line instead of writing everything in a straight line. So I can write the product ID. Let's say product ID. After product ID is going to be a column name. After writing the column name, I need to specify the column data type. Okay. So for product ID is usually numbers, right? And if you remember, when I was showing you the PowerPoint presentation, I said for numbers, we usually use the integer, big int, small int, tiny int, and I think small int. All of these are used for integers. However, the size depends on the amount of data you'd be importing into that table. So if you know that your product ID, let's say we have just 10 products, you can use the int data type. You can use tiny int. Okay. For me, I'll just use the int. That's the int. Before finishing this code, you'd notice that I've gotten a list of keywords that I can select from. I can also add other constraints, but for now, I'll just add the not null constraints because I don't want the product ID to be empty. So not null. Okay. This is one column. To add another column, I need to use a comma to specify that there's another column coming. There's another column name coming after this. So when I use the enter key, I move to the next line, I can specify another column name. Okay. So another column name is product name. Let me put this in lowercase. Product name. And of course, I need to specify the data type. You can use the char or varchar. I don't know the right pronunciation. You can call it char, you can call it char. Depends on what you prefer. VAR. You can see we already have a drop-down list of keywords. So use varchar. Whenever you use the varchar, you need to specify the size. Okay. So if I impute 20, this means this product name will only contain values that have 20 letters. If my value is above 20 letters, it won't be inserted into that column. Okay. So you need to know your product well, your product name well. If you know your product name is not too large, let's say your product name is salt, sugar, fish. These are letters between 0 to 10. Okay. But for now, I'll just use 20, or better still use 50 to avoid errors. Another column name, I can say release date, so that we can try the date data type. I'll call this release date, lowercase, release date. And the data type for this would obviously be a date data type. And here I don't need to specify the size, because every date of value is usually YYY MMDD. I think that's the accepted data format in SQL. Let me write that out. YYY MMDD. Any other format is not accepted in MySQL Workbench. Okay, so back to it. Because I'm done writing the columns, I don't want to insert another column. I don't have to use the comma. Okay. Before I run this, I want to use the product ID as our primary key. So I need to specify the product ID, the product ID to be our primary key. To do that, at the end of this statement, before closing the parentheses, I use the comma and write primary key, and I'll specify what the primary key should be. Primary key should be the product ID. Now, when I run this, I'll get my output, action output. And here you can see the action we ran, and 0 row is affected, but obviously we didn't run into an error because we have a check mark here, and it took just 0.016 seconds. Over here, you'd see that we don't have a table yet. Just like it happened when we created a schema, we need to refresh to be able to see our table. And when I refresh, you'd see there's a drop down here in the tables. And if I click on the drop down, you'd see a product, and also under the information, you'd see the table name, which is product. You'd see the column names, product ID, which is integer, and it's the primary key. You'd also see the product name, which is a varchar data type, and the release date, which is the date data type. We haven't inserted anything into this table, but I can see this table by using this icon. If you click on this icon, it would automatically write this code. I didn't want to write the code because we haven't gotten to that part. But when we get to write our select statement ourselves. But for now, you can just use the icon by the side to see all the data in the table. Okay. Because we just created this table, it's empty. Obviously, we need to insert values into it. I can take this out. I've shown us how we can create a table using the code. Now I'm going to show you how you can create a table using the user interface. So let's use the user interface to create a table. Over here, we can see some buttons. This button is to create a new SQL tab. If I click on it, you'd see a new tab, a fresh tab. This is to open a SQL file. That's if you already have a script and you want to open it, you can click on this. This is to create a new schema. This is to create a new table. and this is to create a new view. What we are trying to do now is create a new table. Okay, so this is where our focus should be. Others are also used for creating functions and also to create stored procedure, but for now we are trying to create a new table. When I click on this, it will create a new interface. This interface, we need to specify the table name, the chassis or the collection. We can add a comment, and here would the schema where the table will be created into will be specified. And also here we are going to create a column name, data types, would click on any of these constraints, and under the index you can specify the index, foreign keys, and the likes. So let's create our table. Let's say this table is customer table. If I create a product table, I might run into error because I already have a product table. I would leave this chassis and collection to be as default, and I would insert my column names. So when I double click on this, you'd see that it has automatically filled in this name, column name for me as a customer ID. I can change it, I can customize it. So let's say cost ID, and it automatically picks the data type as well, and automatically specify that this is a primary key. Notice when I click on the PK, you'd see a key icon next to the customer ID. This specifies that this customer ID is the primary key. NN means not null and UQ means unique. Okay. I can also customize to write the name, maybe first name, the customer's first name. When I double click on this, I can have access to the drop down by clicking on this drop down icon. Here you'd see different data types, and you can select the data type you want. This would use a varchar variable character. That's what varchar means, variable character. You can use this by clicking on this and also specifying your size. Okay, so let's say the size. Obviously, a person's first name cannot be above 50 characters, so we are going to use 50, and you would use not null as well. This will specify, or this will indicate that the column must not be empty. We can also write, let's say, the person's average income. So the customer's average income. Let's say the person is earning $100,000 and 0 cents. Okay. Obviously we have values before this decimal point. So what data type would we use in this case? In this case, we use the decimal data type. Okay. So when we use the decimal data type, we would have to input two values in the parentheses. The first value would be the number that is before the decimal, while the second value will be the number after the decimal. So in this case, if I want to use this particular example, obviously this is a six-figure income. So I would specify that it's 6, and after the decimal point, it should be 2. So this would accept only inputs within this range. If I add a different 0, so let's say the person earns $1 million. If I try to insert this value into this column, it won't run successfully because the value before the decimal point is already above 6. Okay, so you need to make sure the value is within the range. So to be on the safe side, just use 10,2. Only if you know the value you are dealing with is above billions. Okay, but for the average income, this is enough, right? So let's get back to it. For average income, we need to use decimal. You click on decimal, and you inside the parentheses, you need to specify the numbers. 10,2 is what I would specify, and this can be null. So I'm going to apply this. I'm going to click on apply, and the changes will be applied. Before the changes get applied, you would have access to review the SQL script. If you look at this script properly, you'd see that it's very similar to what we created using the we created in the query pane. You'd see that we used the create table, and here they specified the table name. We didn't have to specify the table name in the query pane because we had already set my first schema as the default schema for that particular query. So here what they did was they specified the schema name, and they used a period sign, and they specified the table name. Inside the parentheses, they specified the column names, which is our cost ID, as integer, not null. They also specified the first name column. We used a variable character data type, and we set it to not null as well. We also had the average income, which you use as decimal data type, and we set this to null. It can have null values. We also specified our primary key to be the customer ID. Here we have another code, which is the index. We didn't create this when we were doing the query, when we were writing the query in the query pane. It's not that important, okay? So just click on apply, and the script was run. The script was successfully applied to the database. You can click on finish, and when we come back to this schema, you'd notice that we already have a different table called the customer table. Okay, and I click on the drop down, you'd see we have the column, indexes, foreign keys, and the likes. Under the column, we have the column ID. We have the customer ID, first name, average income, just like we specified using the user interface. I can click on this icon to see all the values in our data set. Okay. We've been discussing the create table and create schema keywords. We've also discussed the data type, that's the int, varchar, and the likes. I want us to use keywords like job table, job schema, alter table, add columns, or add tables. So let me first show you how you can drop a table. We already have two tables here, which is the customer and the products table. And okay, we're already writing a lot of code. So let's add comments. For us to add comments, we can use two methods. We can write a single line comment. We can write a multiple line comment. For a single line comment, we'd use the hash tag. Okay. We can also use the double hyphen. Okay. So with the hashtag, I can write my first comment. Okay. Let me write this here so that our code will make more sense. I can write products, creating the products table. If I run this particular line, no output would be generated. Okay, it won't run. This two hyphens is a way of telling my SQL workbench that the statements I'm about to make should be ignored, as it's a comment just to make it's a comment that is inserted into the script just to make the script readable. These two methods I just showed are used for a single line comment. For multiple line comments, we use the slash and asterisk, or slash and asterisk. whatever you call it, asterisk, asterisk. So I can end it by using this asterisk and the forward slash. So what this means is that anything I write inside this code, so this is a multiple line comment created to show you. Okay, these lines would be ignored. So moving forward, I can just cancel this or collapse it by clicking on this icon here to collapse a particular comment, but I can also expand it and delete it since we don't need it. I just used it to explain so that we can understand. So now we want to write a statement that would drop the customer's column table. Drop. And what do I want to drop? Is it a column? Is it a table? Is it a schema? Here I want to drop a table. So I'll specify the table. And of course, I'll specify the table name. The table name is customer. Now you see we don't have the red cross anymore because our statement is following the correct syntax. I'm going to use the semicolon and run this. After running this, you notice that we don't have the customer table anymore because this table has been deleted. You can't retrieve this table anymore because you've already dropped the table. So always make sure you are dropping the table that you intend to drop to be on the safe side, because once you drop the table, that's it. You can't get it back. Most times companies don't give data analysts access to drop tables because of situations like this when you drop wrong tables. Okay, so we'll proceed. I would also discuss how you can alter a table. So let me run the products table again so that we can see the table. Here you notice we have just the product ID. Okay, from here we can also see, let me just take this back. You notice we have the product ID, product name, release date. We can add a new column. Let's say the column is called product price. Okay, we can add this column to this table without having to delete the table. We just alter the table by using the alter statement or keyword. Let me write a comment that says so I'm going to use the alter. And what do I want to alter? I want to alter a table. What's the table name? The table name is the products table. Okay. So what do I want to do? That is, I'm asking this question so that you understand the idea behind this syntax. So what do I want to do? I want to add a column, right? So I'll specify add column. And what column do I want to add? What's the name of the column? The name of the column is product price. And of course, after adding every column, you need to specify the data type of that column. The data type of a price column will be decimal. Decimal. And of course, we would add the 10, comma 2 in the parentheses. And we can specify not null or null. In this case, let's use not null constraints. And one thing I want you to know is if I run this this statement, a new column will be added at the end of the products table. So the new column will be added after the release date. If I want the column to be added maybe after the product's name, I can specify that by saying after, and I'll specify the column I want it to be after, which is the product name. Now, if I run this, let me run this so that I can show you. Okay, I ran into an error. Okay, so I misspelled the product. It's supposed to be product without an S. I added an S. From the error message, you can tell what the problem is. SQL error message is very easy to comprehend and easy to figure out where the problem is coming from. So I'll run this again, and this ran successfully. Now, when I refresh this, you would see that under the informations pane, I can now see the product price being displayed in between the product name and the release date. I can also run this by using this icon to see the results. Okay, because I haven't added data into this, that's why it's empty. I said I was going to talk about the foreign key, so let's create a sales table using the user interface. Then from the user interface, I'm going to show you how you can write the query. So I'll add a new table, and this table would be called the sales table. Okay, I'll leave the chart set and collation as default. Now I'll add my column names. Let's say the sales ID, sale ID. This would be an integer. I've added this as a primary key and the not null constraint. Let's say I add the product ID, that's the product that was sold. I add the product ID, and of course, this is also an integer. Not null. I add the sales, let's add the sales person. We can give the variable character a length of 50. Let's say the person's full name, so let's just say 100, and not null. The quantity, that's the quantity of the products that was purchased. Quantity. This should be an integer as well. If it's 1, 2, 3, and so on. Not null. And we can add the price. Price, of course, would be in decimal. 10,2, and not null as well. Now, when I move to the foreign keys tab, I can add the foreign key name. So I want to link the product ID, and I'm referencing the products table. Okay, so I'm going to link it with the products ID here in the yes. Okay, so here is the product's foreign key name. The foreign key name is product ID. The reference table is the products table, and here I specify the columns I'm trying to reference. Okay, when I click on apply, you'd see the code. Now let's review the code before I apply these changes. Just like we had in every other queries or every other table we've created, we use the create table. We specified the schema name and the table name. These are the columns within the table. That's the sales ID, product ID, salesperson, quantity, and price. We specified this primary key to be sales ID. The index is already automatically created, and the product ID is used as the index. The constraint is our product ID, and the foreign key here is our product ID. Product ID is referencing the products table. Okay, so this is the table name, this is a schema name, this is the table name, and this is the column that is being referenced. Okay, these ones are set to default. When you're writing the code, you don't need to, when you're writing the query in the query pane, you don't need to include this. All you need to include is the foreign key, the primary key, and this index as well is in default. Only if you want to change the index value. So I'll click on apply, and this script was run successfully. If I click on the show log, it will show me the execution of the code. And if I click on finish and I refresh this, you'd find your sales table. If I click on the sales table and look through the information pane, I would see that I have the sales ID as the primary key. I have the product ID as the integer. I have the salesperson, quantity, and price. Okay. So this product ID is acting as a reference. When we start to extract data from our database, you'd understand the relationship between sales ID and product ID. Okay. So product ID is serving as a link between these two tables. Okay. So if I want to bring, instead of using the product ID, if I want to create a join, okay. If I want to create a join between these two tables, the product ID would be the column I'll use to create a join between these two tables. If you don't understand what I just explained, that's the primary key and foreign key, like I said earlier, make sure to specify in the comment section. I'm going to create a different video. If there are a lot of people saying they don't understand, I'm going to create a different video on how to normalize your data and also understanding primary keys and foreign keys. This task focuses on you practicing what you've learned so far on how to create a database and how to create a table. So you're expected to create a database called the pastry store. You create a pastry table, staff table, orders table, stores tables, and you can input any column you want into your table. It's just an hands-on practical to practice what you've learned so far. I would see you in the next video. Make sure to like, comment, and subscribe. If you have any issues, make sure to specify in the comment section. I'll see you in the next video.